we will see another method, Johansen's cointegration test. Now, Johansen cointegration does not work on one equation. It can suggest you that there are multiple cointegrations. And Johansen's cointegration also tells us the short-term adjustments and long-term adjustments for those cointegrating equations. I am going to use the data price. So this is the data which we are going to use, forward dollar prices and spot dollar prices. So see, this same data, I am going to use it in Eviews. This is the data. Now I have opened it in the Eviews. We will use our mouse click. We will use our mouse click and control to see the forward dollar price first. We will use it because we are going to take it as our dependent variable, and spot, then we are going to take it. We will open it as group. We open it as group. So we have got this forward dollar price and spot dollar price. This is the data I started from month 1, 1979 to 1999, month 12. So this data starts from 1979. I have downloaded this data courtesy to some people, those who have kept this data on the websites. I have downloaded the data. I have not created this data. Thanks to those people, those who have given this data. Okay. Now we will see by Johansen's cointegration test whether there is cointegration or not. We'll go to quick group statistics and then Johansen's cointegration test. Now it is already there, forward dollar and spot dollar. So these are the variables which we are going to take, and we'll say okay. Now it will ask me first whether we should use no intercept or trend, or whether we should use intercept in the cointegrating equation. It further asks me whether I should use intercept or cointegration and var, or intercept and trend, or we can say intercept and trend, or we can use the summary of all. The summary of all may also help us. What should we do? Which choice we can have? We can have with no intercept, intercept or no trend, intercept no trend, or intercept and trend. Trend means time. Or we can use intercept and trend in cointegration, intercept and var. So those are the things which it asks you. So that decision you'll have to take it. You can see the summary. From the summary only you can use it. How many lags I can use, what I should use, whether I should use intercept or not, or you can use any of the things which you have seen it. How when you have seen the unit root. From the unit root, you might have decided whether I should use the intercept or not, whether I should use in trend or not. Those things should be used here. Okay. So I'm going to say, okay. Now it asks me delete untitled group. You say yes. So it is giving me now the results of Johansen's cointegration test. It gives me test. It tests from 2 points. One is eigenvalue and second is trace statistics. You can observe both better, or you can observe trace statistics or eigenvalue. Now, what is the null hypothesis? null hypothesis, there is no cointegration or there is a cointegration. But it does not tell us with only one equation. It tells us whether there is one equation, two equation, three equation. So the first one is hypothesized. See this first column, hypothesized number of cointegration equation. It means it says none. And it says eigenvalue 0.052519 and trace statistics, and then it tells me at 5% what is the critical value of this. Now trace statistics is more than this critical value, so probability is 0.0118. It means we reject the null hypothesis. We reject the null hypothesis means there is no cointegration. So there is a cointegration number. There is a number of cointegration. There is maybe more than one, maybe not zero, but maybe more than one. Now at most one. It is again saying that there are two cointegration. We cannot reject the null hypothesis that it has got only one cointegration. It has got more than one cointegration. So trace test indicates two cointegration equations at 5% level. At 5% level. Trace says there are two cointegrating equations. But eigenvalue says that number of cointegration none, at most one. So eigenvalue says there is, now if you says this 0.013, so it says there is no cointegration at none, because we cannot reject the null hypothesis. It is value is more than 0.05. So 0.0700 is more than 0.05. We cannot reject the null hypothesis. So it says there is no cointegration. But when we go to the second cointegration equation, it says there is more than one cointegration. So this result confuses us. This result confuses us. Nothing to worry. What you can do, you can change the data by taking logs. Log of forward, log of spot, and then you see if you get the correct results. If you get the correct results. So log will help you. Log can help you to get the correct results. So then you will have one cointegration or two cointegration. It will be decided. But this result says there are confusing results. So trace value says there are two cointegration equation, but the eigenvalue says there is no cointegrating. There is no cointegrating. Anyway, what we will do, we will now go to this cointegration test we have already done. We can also see again Engelbringer causality cointegration test by single equation test, or we can see the system Johansen system cointegration test. We will go to now quick, and after this quick we can estimate VAR. Now in estimating VAR, because first is a unrestricted VAR or vector error correction. So we will see that there is one cointegration equation. We will assume it is going to work with one cointegrating equation. So we will use the endogenous variables forward dollar, which is your dependent variable, and spot dollar, which is there, this one. And it says do not use C, that is constant. So you can simply say using this data. So lag intervals for endogenous variables let lag be 1 or 2, and you say okay. So let us see. And cointegration. Now cointegration, again you'll have to decide it. It is intercept in cointegration var, no intercept. We can also try now, because these are giving various different results. Here also we can also try using intercept and trend, because we use the number 3 choice with intercept, no trend. We can use it intercept and trend. That will also help you. So let us try again. Let us try again using the Johansen's cointegration test. View cointegration test, Johansen's cointegration test. Instead of 3, we will use 4 with intercept and trend. We'll say okay. Let us see now what is the situation. Now in that case, it says trace also says none of the, there is no cointegration. Similarly, eigenvalue also says there is no cointegration if we use. Now let us view again. I'm going to use it again. So you have to see Johansen's cointegration. Instead of this, we will use intercept and trend. Intercept and trend, number 5. Number 5. Let us see the number 5. So what is the result now? Number 5. Okay. So it is again number 5. When we use eigenvalue says there is going to be no cointegration, and trace value says there are going to be 2 cointegrated equations. Okay. Now, if we Johansen's cointegration test, if we use it, number 2, intercept, no trend. So then what happens? What is happening now? So it is again coming at those results. Now let us assume there is 1 cointegration. Assuming, because if we take it up, this one, Johansen's cointegration system test, and if we take it at number 3 with 4 lags, and it says okay, so then it says there are 2 cointegration, but here in this case it says no cointegration. But let us assume this data, because in such cases, what we are going to do, I'm going to tell you in next session. In such cases, what are the things which we can do it? I'm going to take it up now after some time in the next session. What we should do in such cases, we will work it out. But let us learn. In this case, we are going to go for this Q group status, Johansen estimate equation or estimate var. We will go for estimate var, and we will go for vector error correction, because in this cointegration equation, if it is there, so then we have to do this vector error correction. So our forward dollar and spot dollar. And we are going to find out cointegration. Let us say number 3, let it be there, number 3, and we have that. Now see the cointegration equation. One important thing you have to note down, that this cointegration equation, the coefficients of cointegration equation is minus 0.3107. It is a very good sign. It should be negative. It should be negative if there is a cointegration, but it should be statistically significant. Now the T-stat for this is given as minus 3.93551. It means this is going to be statistically significant, because if you see this value, it is less than minus 1.96, means 5% level, significance level, even if you take, it is going to be statistically significant. It means there is a cointegration, 1 cointegration. Now, what are the coefficient of this? This one is cointegration. What are the variables? This variables is spot lag price, spot dollar lag price. And for this is minus 9.98605. and it is statistically significant, minus 28.13, and there is a constant also. So this one is called cointegrating equation. Now, as in the Engel-Granger test, we used from this equation, we used error of this equation to make the second equation. But in Johansen's cointegration, it simply tells us the equation. It is cointegration equation. The coefficient is minus 0.31073, and the inside the bracket, this whole thing will come. Whole thing will come. Lagged forward price and spot forward price. This is one lagged price, and there is going to be constant. I will show you. We will make the system equation, and you will come to know how this equation is coming. How this can be written. Sorry, how this equation can be written. And then difference of forward lagged price for lagged price, then difference of second lagged price, because we asked the system to use 2 lags. We asked the system to use 2 lags. And then lagged first difference price, and then difference of the second lag. Difference of the second lag, then there is a constant. So we have got one cointegrating equation. We have wanted that there should be one cointegrating equation because we had some problem to tell you how many cointegrating equation is there, but we are assuming that it is having one cointegrating equation. This happens with the data. That we will learn after next session, that how we can handle such data. Which model we should use, that I'm going to discuss it after some time in the next session. So cointegrating equation, the coefficient of this is cointegrating equation of this. Then your difference of first lag, difference of the second lag, and then the independent variables, difference of the first lag and difference of the second lag. Okay. Now let us go to this proc. Go to proc, and we will say make system. We'll go to proc, P-R-O-C, proc is written. We'll go to make system, and we will say order by variable. Order by variable. Variables are C1, C2, C3, C4. If we name it, if we name these variables, so let it be this. This one is C1. Cointegrating equation coefficient is C1, and then forward $1, that is original cointegrating station, which is there, and then spot $-1 is there, that is difference, first difference that we are going to, sorry, not first difference, but lagged, sorry, not first difference, but lagged. Now we will go to proc. We will say make system order by variable. Now you see, system equations have been framed. First one is difference forward dollar value. This is automatically framed by the system. So what is the equation? Difference forward dollar is equal to C1. C1 is coefficient of cointegrating equation. What is cointegrating equation? That is lagged forward dollar minus 0.96052555219. You need not write so many decimals. When you can correct it, you can write up to 2 or 3 decimals. So when you are writing the report, you should write the report in a very neat and presentable way. It says so many decimals are there, but you can reduce the decimals up to 3 or 2 into spot lag price plus constant. Constant is 0.00. See, here the constant is there, 0.003605. Similarly, the constant it is coming. Now, similarly, now this coefficient of lag price is minus 0.98053 minus 98.053. So this is the coefficient of this. Now, this whole equation, this one up to the first bracket, it is called cointegrating equation. It is called cointegrating equation. And all others, that is your vector error correction. First one is C2. Now C2 is first difference of the lagged one. That is minus 266. So this is there, but difference it is not written there. D forward minus 1. Similarly, C3 difference forwards lag 2. C4 difference spots lagged first lag. C5 D spot second lag difference. So now C6 is your constant. This one is C6 your constant, which we have already seen it here. C6 is the constant. Now you copy this first one. You need not see the second one because our independent variable is forward dollar. So we are not going to see the second dollar. That is it. That is actually when we create the var. So var sees both the equations have been created. So but don't worry about that. So you copy this and then go to quick. You can go to we can go to view also, but we will go to quick. And then we say estimate equation. Say okay, and you have just paste it, and now you can, whatever you have copied it, we will paste it in the estimate equation. And same thing now it is coming. Now we can use this because cointegration has already been calculated. The short term, long term, all these things have been calculated. So we can now estimate the equation with the least square. Say okay. So now it is very clear. It is a simple OLS now. It is simply OLS now. Dependent variable is difference of forward dollar. And your equation is this. Now C1 is coefficient of the co-integrating equation. Now in earlier system it was not known whether it is statistically significant or not. So we can see the probability now. It is less than 0.05. So it is statistically significant. It is negative. It means there is a co-integrating equation. C2 is your C2, C3, C4, C5, C6. Basically, they are your VECM, vector error correction things. So C2 is negative, but C2 is negative, but it is less than 0.05. It is statistically significant. C3 is 0.003688. But the value is more than 0.05. It is not statistically significant. What is C3? C3 is 1, 2, 3. That is a difference of second lag of forward price. So that is not statistically significant. 0.9752. C3 is not statistically significant. C4 is what? That is spot lagged price. That is statistically significant. C5 again, probability is 0.2771. It is not statistically significant. C6 is not statistically significant. That is constant. So it means, constant is not statistically significant. Constant is not statistically significant. C5 is not statistically significant. C4 and C1 and C2 are statistically significant. R square is 0.20. Durbin-Watson is 1.98. Durbin-Watson is near 2. There are 2. It is now very clear. So there is no problem. R square is less than Durbin-Watson. R square is less than Durbin-Watson. So there is no. Now let us see if we can work on this equation. This can be saved. This equation can be saved. This equation can be saved. So we can use this equation view and we can do the coefficient diagnostic. Coefficient diagnostic may multicollinearity, whether there is multicollinearity or not. We will see the variance inflation factors. Now see, all the values of C1, C2, C3, C4, C6 is constant, so there is no problem. So we are not seeing, so there is a relationship between C1, C2, C3, C4. all the centered values are less than 5, it means there is no multicollinearity in the equation. We will go to view diagnostic, coefficient diagnostic. We can do the walled test. Walled test, we can see whether the coefficients C1, C2, C3, C4, C5, C6 name. Don't take C6. So whether they are 0, so our null hypothesis is C1 equal to C2 equal to C3. You can also check it individually, whether they are 0. You can see the probability also, whether they are, that T-stat will also tell you, but you can do the wall test. Wall test also. So in both the cases, you can see C4 equal to C5 equal to 0, whether they are all 0 or not. So we can do this wall test. So we'll say, okay. So it says probability 0, 0, 0. See chi-square test. Chi-square say probability 0.000. So it means we reject the null hypothesis. What is our null hypothesis? C1 is equal to C2 is equal to C3 is equal to C4 is equal to C5 is equal to 0. It means they are not 0. All are not 0. So they are different. And this also can be seen from the probability which we have when we made the equation, OLS equation. We can see it from this. Now let us see the residual diagnostics. Residual diagnostic correlogram. Correlogram will tell us we are going to use 36 lags. You can use 36 lags. You can use 20 lags. You can use 12 lags, whatever you want to use it. You can. So I'm going to use now 12 lags. Now in this case, 12 lags are there. Now all the autocorrelation, see the dotted lines and the fluctuation in the dotted lines. All fluctuations of all autocorrelation, they are falling with the 95% confidence level. Similarly, partial correlations also falling in this. So it means the lagged values, they don't have any kind of autocorrelation. And now we come to the view again. We will do the residual diagnostics. We will see the histogram, normality test. So normality test is there. This appears to be normally distributed, but there is one data which is an outlier, that this one between which is less than minus 0.03. So this one is creating the problem. That is why the Zark-Bera test is showing 0.000. It is less than 0.0. It means there is a problem. There is a problem in this case. Anyway, now we come to the residual diagnostic serial correlation LM test. We will use the 2 lags. Let it be 2 lags. So we'll say this one is, there is serial correlation. There is no serial correlation. There is a correlation. So it means this Brosh-Godfrey serial correlation LM test says there is no correlation. We cannot reject the null hypothesis. It is 0.443. Okay. Now we come to the next one, residual diagnostics, heteroscedasticity. Heteroscedasticity, again, we will use Brosh-Pagan-Godfrey test. So we'll say, okay, and all the regression coefficients, all the variables are given here. We will say, okay, and it says heteroscedasticity. When there is a homoscedasticity, there is a heteroscedasticity. If we see the chi-square, probability chi-square with observed R-square, is 0.3331. It says simply there is no heteroscedasticity. There is a homoscedasticity. There is a homoscedasticity, means variances are constant throughout this. So we can accept this equation, though the Johansen's cointegration test, it had some problem with us in the beginning, but when we assume one cointegrating test, so it was okay. So we can make one cointegration equation and then this, and then you can forecast also. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work.